it's going to be one of those funny videos. That's because it's all about Ohm's law. Right. Short, didn't I? I said we're going to keep it to 5 minutes per video on this. Ohm's law states that voltage is directly proportional to the current and the resistance. V equals IR. It's vitally important you remember that. Now, do you remember at school when you did those funny triangle things? With, in this case, V at the top, and we'll put I and R at the bottom, and it was one of them strange triangle. I'm doing really well at this drawing upside down thing. It was just one of those strange triangle things that look like that. And if you knew 2 but not the third, you'd cover one up. So if you didn't know I but you knew V and R, you could cover up I, and you get V over R. Good? No? Well, you can. That's the advantage of the triangles. This is the Ohm's law triangle, which I'll try to write upside down. I'll put it down there, can't I? Triangle. This is where we discover I can't do N's upside down. I probably can't do G's upside down. I can't do anything upside down. There you go. It's the Ohm's law triangle. So that's your view. Okay. If you got one, you can work out the others. You need to remember that. Quite often, and we'll do an example, we know the voltage. V equals 120 because I wanted it to. And R equals 100. That's it's 120 volt. That's 120 ohms. And we want to know what's I. Oh, I won't be the right way up by the time I've finished all these videos, will I? What's I? Well, that's easy. I've got rid of the triangle. It's V divided by R. So if we go V divided by R, which is equal to 120 divided by 100, the answer is I equals, oh, can't see. Right, what does I equal? I've forgotten what the question is now. 120 divided by 100. 1.2. 1.2 amps. That's 1.2 coulombs per second. Remember coulombs? It's that simple. And it's very important because you need to know what's going on in your circuits. Although every circuit has resistance, a dead short has a resistance approaching 0. So if we said, what is the current in a short circuit? Well, we know what the current is. I equals V over R. Yeah. And we know that V could be, well, it doesn't matter. What should we have? What should we have for V? Let's just say it's just 1 volt. V equals 1 volt. That's a V, not a U. Okay. And R equals 0 ohms. Now we're going to say what happens next. What happens when we go 1, let's do continental ones, 1 divided by 0. I equals 1 divided by 0. How many times does 1 go into 0? There's a number file video that will tell you the way to do this. We don't have time. It keeps going into 0. It never stops going into 0. It'll keep going into 0 long after the cows have come home, long after time has ended, and so I equals funny figure of 8 thing on its side, which I have major objections to, amps. I shall quite enjoy infinity, it's fun. you need to know if that's going to happen. And in the next video we're going to look at power, and then we'll go on to series parallel resistance networks. That will be video number 4. So video number 3 is going to be power. It relates into this. It's very useful to be able to define voltage by current and resistance, or resistance by voltage and current, or the current by voltage and resistance. And we will do a lot of that in the power equations so that you don't have to use necessarily the simplest form. Okay, I hope that's under 5 minutes. Thanks for watching. Quick note, don't tell anyone, but I've been promised the loan of a Silhouette 2.5K profile to dismember and put back together in the near future.